type of precast product. We're a little unique. We're pretty large. We do anything from custom structures to data centers, parking structures to building envelopes. We have our manufacturing plants. This is our largest one here outside Sacramento. We have another one down kind of between LA and Las Vegas, and from here we're able to service all these states in the dark gray. We also have business models where we service clients, core clients nationally across the U.S., where we'll run the engineering, the designs, the submittals, the installation, and we'll utilize a precast partner to manufacture product for us. A little bit about us: we're 60. I can't do math anymore, but 64-ish years. But we started high-end architectural precast. That's what most people think about when you talk about precast, and I'll get into what that is, and then I'll show you kind of where that's evolved over the last 60 years. But this is where we're at today. So this is our Woodland facility. We are in this little building right here. And so I'm sure you guys have heard the term lean, but basically all we're trying to do is be as efficient as we manufacture product. So everything we do is based off raw material. We have a large, I think it's 200,000 square feet. I'm not sure if I put it on there. We have a 6,000 square foot indoor facility and about 140 square feet of rebar kitting. So we'll do all of that before we get to the decks and manufacture our panels. And there's always some sort of level of product finishes. And then what you're mainly going to see is large amounts of storage space. When you're pre-manufacturing a building, you're not casting a panel for, hey, this is the first panel that goes up in the erection sequence, we're going to cast that. We're always worried about labor and keeping our costs down. So we're going to manufacture based on efficiency. So you may be casting a level 2 panel one day, the next day may be a level 6. And so when I only say that is we want to have 80% of our buildings cast before we go to the field. That's just ways we keep costs down. This is our most famous building. We did manufacture and install the Apple Cupertino headquarters. So this is the largest precast building in the world. And we also did 2 standalone parking structures at the same time. So it was over 6 million square feet. This kind of shows, a little bit kind of what we're capable of. We have 150 engineers on staff. We are not a manufacturer. We are an engineering company that manufactures. And I say that because we will innovate job to job depending on what's needed for that project to add the most amount of value. And so here's just a couple shots from us doing that project. I'll skip through these. All right, facade. So this is what most people think about when you say architectural precast concrete. 4 to 6 inches thick. You can do colors, different types of finishes, bedded stone, brick, all sorts of different stuff. It can do just about everything. The trade-off, or the negative aspect of architectural precast is the weight. And so here in California on the West Coast with seismic activity, you're always on big towers. You're trying to keep your building weight down, reduce your base shear, reduce what your lateral systems cost and stuff for the buildings. So back in the 80s, we were one of 3 companies that helped develop glass fiber reinforced concrete. So this is basically instead of using reinforcement like a metal mesh or rebar or stuff like that, it is a glass fiber that's in our mix. What's really cool about this is it keeps it lightweight. It's all supported on a metal frame. And so instead of 50 to 75 pounds a square foot, you're talking about 18. Now the cost is higher. There's a lot more labor that goes into manufacturing this. But it's a spray applied mix, so you can still do like really fluted designs, ins and outs, but you're keeping that skin only 1 inch thick instead of like a viscous fluid like concrete where you have to pour up a full form, right? That's what creates the weight. The trade-off here is you're not going to embed products like stone and brick and things like that. And so then we also have kind of a hybrid system we made. 89, 90. This is probably the workhorse for us in California. Kind of mixes both, where it's more economical than the FRC, but it's still lighter weight. It's around the 30 pounds a square foot. This is the product I actually used with Adam on the downtown commons, the Kimpton Sawyer downtown. That was all of our CCAP product here. But really what we do, and this is an image of the lightweight product, but you'll have the skin, you have insulation, we do glazing windows as well, so we're trying to develop a full envelope. We go out to our clients, so kind of a one throat to choke concept where, hey, you come to us, we're gonna do the full exterior for you. We design all the metal, the connections back to the structure, and we have to coordinate with the architect, the SEOR, the contractor, how that's going to work, how the loads get back to the structure, who's doing the embeds, all those types of coordination. And then give you a taste of like what we're capable of. So this is a building we completed last year out of Mission Rock, which is kind of by this Giant Stadium. We did a bunch of these buildings, but this is that hybrid system. So this is about 2.5 inches of concrete. We embedded a glazed thin brick. Here's another shot of a building on that same campus. It is GFRC. The complexity here is on all the ins and outs. This is where most of our engineering, our modeling, and water intrusion, that's the complexity of this build. And then the last building on this campus was traditional architectural precast concrete. This is my favorite because I did it. But this was pretty cool because it's full thickened concrete, but it's 70% glass, and we still panelized it, installed the windows here in the plant. So there was some really cool engineering. We did a lot of pre-stressed cables in these panels to help make sure they don't crack because they are the weather barrier. Right? So we have a lot of versatility in what things look like. Here's a job we did in San Diego, tumbled brick. There was a bunch of buildings built in like the 60s, and we had to match the exterior. So we were trying to like mimic old brick and cast it into new panels, things like that. This was with Gensler. Here's a job in San Francisco. We embedded terracotta into the concrete, had multiple colors of concrete. So we can do some pretty cool stuff. Here's one of the latest campuses, a biomedical campus in San Diego. We just finished with Clark Construction. The other products we do is we do a lot of parking structures. The difference between precast and like a cast-in-place parking structure and when we make sense versus them is going to be speed. So precast is very large pieces, 60-foot spans. We're going to go out and install a building really, really quick. The other benefit we have is integrating finishes. We take all of our years of architectural experience, and these are structural elements, structural members that you're including architectural mixes, form liner, sandblast, and things of that nature. So instead of going out and cladding a parking structure and say like a metal screen, we can do this. And so you'll see, actually, we have a decent amount of parking structures on your guys' campus. Park structure 5. It's one of my favorites.
Is that a picture of parking structure 5 right there?
This one is.
Looks like it's a casino.
No, I can't.
It does look like a casino parking lot.
Can't remember which is. I do have one, I believe. We'll see. I swear. So this is like, we'll see this. A lot of jurisdictions will dictate whether you have to wrap your building or not, but this really takes away our value, right? It's like, okay, the best thing we can do is integrate finishes and take your facade budget and put it into the structure versus like cast in place. But.
One question?
Why would you need to wrap a building?
So different jurisdictions will have different requirements, and so some, like in South Bay, San Francisco, their local building department wants to hide garages as much as possible, and they feel like if they wrap it, that's their key. And to me, it's stupid. It adds money to the buildings, makes things not pencil as much. But
a lot of times you can't tell. Like I remember when they were building the Kings Arena, Golden One Center, all these people were up in arms saying, "Where's everyone going to park?" And it's like hundreds of thousands of people filter downtown every day to work, and the Kings game starts at 7 o'clock. Those people are gone by then. But you don't really see them. So like a lot of buildings, high-rise buildings, they have below ground parking structures. Yeah. But sometimes they have 4 or 5 levels of above ground parking structures, and you can't tell from the street. It looks like all the rest of the facade. When they put screens up and things to cover up those parking areas.
We'll do a lot of like when there's a large residential tower that we have the first 5 levels are actual parking. We'll put the same facade panels that we have, even with windows, or sometimes they're just openings with no windows for airflow, but we'll put them over the parking structure to hide it. So when you're looking from the street, it just looks like all residential builds. But one thing that we created here at Clark Pacific is the hybrid moment frame. So it's a moment frame technique that we use. We post-tension our pieces together. It's the most resilient lateral system you have. So if you have a designable earthquake, it snaps the building back, and it's operational. And that is something that's very unique about precast. And so in this type of a parking structure, we do a lot of universities because the women students feel safer. There's a lot more airflow. You can see from one corner of the garage to the other. There's no shear walls and stuff like that. Typically, this makes sense when we're larger parking structures. So we do a lot of what we do is going to be 4+ levels of elevated parking. Have you guys, I'm sure you guys have heard of data centers. Do you guys know what data centers are?
Yeah.
So this is the biggest thing that's going on in the industry right now. A lot of markets, especially in California, are pretty soft with interest rates and whatnot. Data center builds are going crazy. So they're going everywhere, and not just in urban environments, but rural environments as well. large scale buildings with heavy loads. So they'll be putting equipment in there that are 400 pounds a square foot. We, as a precast industry, we greatly benefit from that because we have ways we can build very strong, stiff panels that allows us still to span 60 feet, go really fast, and it's been, I think it might have. So this would be like a typical data center.
Are those all like cooling?
Yeah,
units?
it's
Oh, wow.
chilling. They're huge. They're always on the roof. So we'll come in. We'll do everything from basically foundations up. So columns, beams. And this is going too fast. The walls on the outside are load bearing. So instead of like a steel building where you have metal frame, columns, beams on the exterior, our panels will go directly to the back of our wall panels. So they're serving as the enclosure, the lateral system, and your gravity loads. Depending on what the seismic activity is, different ways to handle the seismic criteria. But it's kind of cool. We have these panels casting today, so we'll probably be able to see them. But it's a back layer of concrete, which will be all your structure, your gravity, the lateral loads. Then it has a layer of insulation, and then an outside layer of concrete. And they have pins. It's basically a composite section. But these have really good thermal ratings. It's like more like warehouse buildings, not necessarily the high-end facade stuff that we do. But they're money makers, so we like that. Double T's are your most common structural product when it comes to precast. We do a lot of these for parking structures and for data centers. What's unique about precast compared to cast in place, so when you think about the most ineffective shape, it's a rectangle, right? And they do that with cast in place out in the field because it's cheaper to form up a flat slab and pour it. So you're using extra material and you're not spanning as far. Right, when you pull material away from your neutral axis, let's think of like a wide flange steel beam, right? There's a reason why it's an I. We're taking the material, pulling it away, makes it stiffer. You're a stronger element with less material. We get to do the same thing with precast because we have built-in formwork. So like our double T, instead of just having a rectangle, we're pulling material away from that neutral axis, throwing in pre-stressed cables, and that's what allows us to span very long and have very heavy load capabilities. I'll just flip through the rest. Finishes, I want to just hit a little bit on this and then we'll go out and do our tour. Yeah.
You guys do post-tension concrete?
Pre-tension.
Pre-tension?
Yes. So we may, I don't know, we'll probably be able to see some today, but basically you pull the tendons before the concrete goes in, it pours overnight, and then you cut the tendons when you come before you strip. It'll actually add camber to your double T's. You'll see it when you're out there. The biggest difference between pre-stress and post-tension, anybody know? Okay, so post-tension, you have sleeves going through your slab, right? So they're never bonded to the concrete. So let's say you pour a slab, somebody cuts a cable, that cable can shoot out, and you got to have a lot of coordination around that. With pre-tension, your cables are bonded to the concrete, right? You're tensioning before, and so you don't have to have them sleeve. The concrete goes on. You cut a tendon there, nothing happens, right? You lose capacity, but that's about it.
I never knew that.
Yeah.
The difference between pre-tension and post-tension.
Contractors, am I right? Okay, so finishes, we do a lot, and I'll get into architectural finishes, but there's sustainability. I know it's in every single university, everybody's talking about it. And we're preparing in case there's standards or changes that are required. But as of now, people aren't going to pay extra money for it. So we're trying to do as much as we can at zero cost premium. So we do lead the nation in cement replacement. Right now, our mixes are above 25% cement replacement. We do that with different levels of SCMs. Do you know what cement and concrete does and why it's so important? Okay, so cement is like your glue, right? It creates a hydrothermic reaction that starts your curing process for the concrete. And the cement is the key ingredient that adds that energy to kick that process off. So when you pull it out, you have to replace it with something that's adding energy. And that's what's challenging. A lot of times you can replace cement, but it takes longer to cure. Well, if longer to cure means your formworks are up longer, or you're not stripping panels, and costs a lot more money. What's cool about precast, doing it in a facility, you have other ways to add energy. So for example, we'll do an SCM, we use a lot of what we call aluminum slag. We'll heat our decks to like 120 degrees Fahrenheit, not super hot, but warm enough. That extra energy will kick off that curing process faster. So we're still able to strip our panels 12 hours later. You can't do that in the field or in situ types of situations. So We're trying to get to 50%, yeah.
Does it like increase the risk of it cracking when you heat it up and have it cure faster?
That's a great question. When you do cure fast, we always are susceptible to shrinkage cracks. Okay, so concrete does shrink, and the faster that moisture goes out, the more susceptible you have. That's very critical when we're talking about facades. That's at all concrete cracks. So there's a difference between like an abnormal crack and micro fissures. But it is something why we spend so much R&D, because it's, when you get to a large scale and you're in manufacturing, if you have issues with your mix, you're sunk. There's nothing you can really do. So a lot of time and energy goes into it, but it's a whole chemistry. There's a bunch of additives and different things that are involved in mix design these days that can help that process. And then a lot of trial and error.
You guys do all your own mix designs?
Yes.
Obviously?
Yeah, we will stop by to finish this lab and I'll show you guys what we do there. You'll see this today, but this is just kind of a general board of, hey, these are what's capable of different concrete colors. The lighter the colors are done with sands and aggregates, the darker the colors have pigments in it. Here's different type. This kind of goes from like least or most affordable to least affordable. I got a lot of architects who have a champagne taste but a Bud Light budget, so I'm always trying to push them to the right direction. So form liners is a great way to add depth. These can be anything, rubber, typically less articulation or less depth, but you can make them. We make them out of rubber molds. Anything an architect dreams up, we can create with these things. Our most common finish is a sandblast, but we also do varying levels of sandblast. This is actually Sac State Engineering Building.
Three hours plus. What's it called? Tischwang? Yeah. Anybody know how to pronounce it?
What's cool about us though is it's one color of concrete, and so when you guys go check out that building next time, it's only one mixed design. And what we did was a dark sands, dark pigments, white rock. And so the more you sandblast, the more you take out your cream layer and you expose more aggregate. And so when you step back, you see more white rock. And when you step back, it looks like multiple colors. So instead of, we can cast multiple colors at once, it's more expensive than this. And so I always that's where I try to get involved with architects early on to say, okay, what's your budget? What levers can you pull to add your depth and color changes that fits within that, right? And not get them in falling in love with something that they can't afford. We do lots of other stuff where we embed product. I think we have a job casting that you'll see out there that is embedding stone and terracotta. We do a lot of thin brick, so it's like basically faux brick. It's a 1/2 inch thick brick that you'll pour concrete over. It looks like it's brick and mortar, but it's not. So I think we have some examples out there. Terracottas, tiles, color treatments. This job on the upper right was a job we did in Oakland, and the city commissioned a piece of artwork on the side of it. So actually I put panels here in the plant and had an artist come in and paint them before we went and erected. But this is a whole thing we do with sample processes, from small scale chips before we even get brought onto a job to, you'll see a lab, perfect little measurements, and that's not going to be reality when you're talking about a natural product in your batch plant. So we usually move into human scale samples, something that's coming from our batch plant, and then each job, especially if it's a higher end facade job, is going to have rounds of visual mock-ups and performance mock-ups to make sure when 600 panels get to a job site, it's exactly what the architect was expecting. And just benefits of prefab. I'm just going to skip to this slide here. I'm always trying to tell people like Adam to get us into a job early, because it allows us to provide the most amount of value. Why don't people want to do that? Well, they want to keep it competitively bid. They don't want somebody to feel like, hey, this is our job. They want to keep control over the cost. And so a lot of times you can get on a job a little too late, which is fine. You're going to get competitive bid numbers, but you're not going to get the true value because you're not going backwards on your schedule, on your design development drawings. And a classic example of this is if we're doing a steel building with walls on the outside, people really don't know that, hey, for $3 more, we can take gravity, remove your steel, remove your base frames, do lateral system for you guys. Instead, they'll have all that in their steel package. I've already bought it out, and then I'm just doing wall panels on the outside. For me, it doesn't matter. I'm just manufacturing pieces, but for the building as a whole, you could have saved a lot of money, right? Versus them thinking, if I wait, I can go into 3 different precasters and have it more competitively bid, right? Sure, I might make an extra point or two of margin if I get in early, but it's still going to save the job, overall value and schedule. So I'm always talking about design for manufacturing, logistics, and assembly. And that's why we put a lot of our engineers up front in our pre-construction and sales services, is to get the most amount of benefit. So I run our sales department here at Clark Pacific, and if I make a decision early on, I can swing a budget price 5%. Right? Once it gets sold and it's in project management, they fight tooth and nail for every half a fucking point of margin, and you're not making major changes for the job. And so that's kind of our theory. But any questions before we go out and take a walk?
In terms of like the construction part, how, I mean, it depends on every project, it's different, but like how much time do you like save just like with the whole process of precast and precast concrete?
Sure. A typical size data center, we're saving 2 to 4 months on your structure and another 2 to 4 months on your mechanical platform. Yeah, so we're saving 4 to 6 months for the project schedule. 4 to 6 months. If you open a building that early, they get access to revenue. Data centers are making millions of dollars per month, so that ends up saying, okay, well, even if I pay Clark Pacific a little more to go build this, I'm going to get access to $20 million. Makes it pretty simple. When it comes to facades, the taller the buildings, we're going to save a lot more savings. But we can do, I don't know, 4,000 to 6,000 square feet in a day of wrapping something. So like, it really depends on the material we're going against, whether it's stick build, curtain wall, but we will be the fastest. So.
What are your liquidated damages on a data center?
Too much.
I'm just curious.
No, I mean, I try and get them down to like $25,000 a day.
$25,000 a day. So we've talked about liquidated damages in classes every day that you're over schedule. And liquidated damages in California, at least my interpretation, it can be punitive, right? It's really due to lost revenue. So that means these guys are making at least $25,000 a day.
Oh, they're making so much more than that.
Yeah.
Luckily, every market, you have different amounts of leverage. Data centers, where they're really relying on us and our schedule, we can kind of dictate terms a little bit more. And a typical structure, so if I go after a structure, I know about 45 to 50% of that cost is the structure. Maybe 10 to 15% is going to be your facade. On a data center with all the equipment and servers, the structure is 5% of the building budget. So for them, they're like, they don't give a fuck about cost. It's about speed and certainty. And so that's what we sell.
Sorry, last question. What about like solar plants? Like, do you like work with like utility companies to like build out solar plants?
No, we don't typically get involved into solar. The only thing we'll do there is like a lot of our parking structures will have solar on top. So we'll help coordinate that and take the loads down through our structure. We also have a bunch of solar. Our plants are 100% off our own energy. But cool, good questions. Anything else before we get going?
All right.
Okay.
Walking shoes on?
Yeah, you got shoes. Everybody, if you don't have PPE, I got some extra stuff there. When we get to the metal shop in the indoor facility, I will ask you guys to put in earplugs. They're out there, so I'll let you guys know. If not, people will yell at us. This is what I usually start with. With architects, you saw this in the photo. I've never had an architect come up and say this is the mix I want. It's always custom, but this is just supposed to give a representation of what we're capable of. You'll notice on these samples, this is medium level sandblast. This is a lighter level sandblast. So when I say about taking off that cream and showing more aggregates, that's what it's about. But a lot of my conversation, depending on like the panels, if they have like a lot of openings, is not as important. But if they're large format panels, you're going to have a lot of pieces. We're casting over 3-4 months, and so you could be casting when it's 50 degrees outside. You could be casting when it's 100 degrees outside. Everything will affect color variation. And so we're trying to, my job is to always de-risk the job and try and get a color that I want to cast. The architect's job is always to push me slightly outside my comfort zone. And so we'll talk about the different price points and maintenance and things like that. But do you guys know what efflorescents are? Efflorescents are, as concrete cures, every concrete effloresces. As concrete cures, minerals will come to the surface and you can kind of give it a cloudy appearance. And so the darker your colors, the more of a chance. You can even see these ones have efflorescence on it right now. You can clean that off with a sandblast or a chemical rinse, stuff like that, but it's another part of the maintenance program. And you typically will have higher color variations the bolder colors you use. So those are always conversations I'm having. All right, follow me. Here's an example of like the thin brick. You'll see they wanted a colored mortar, so you'll see we had 2 different colors of concrete that were actually poured at once. But these are all typical types of stuff that you can do with your formwork and things of that nature. This is a good example of like our samples and mock-ups. So this is a job we're actually doing in going up in Folsom, the medical office building. But we started with 4x4s, trying to fit in as many features as we could. Then we moved to a visual mock-up where we're also including windows, elements, and things of that nature to get your final feedback before we get to first of series casting. These are all traditional precast, full ticket front. This is our hybrid system where it's that thick 2.5 inches of concrete on a metal frame. This is definitely what we use the most amount of product on. And you can, again, you can incorporate a ton of different finishes and things of that nature, but the side profile is what you guys should take a look at.
If you guys look at the side, you can see how thin it is. And then they'll put insulation on the back. Exactly. Yeah, 100%. This concrete's super heavy.
So this is a good representation of like a typical panel before we ship it. One of the biggest price factors for us is panel size. I think I might have mentioned it, but we're trying to go as big as possible. Some of our costs like stripping, storage, handling, putting it on a building, it doesn't matter if the panel is 20 feet long or 30 feet long, it takes the same amount of time. That's cost that's divided over smaller square footage, price goes up. So we're always trying to get in and say, how big can we make these panels? A lot of times like shipping requirements, you know, we got to check overpasses and all those types of stuff. Can we actually get the panels to the job site? This is GFRC, okay? So what you're seeing here is a glass fiber reinforced concrete, and that's what gives us a lot of the articulation, but it stays hollow. So it's a very lightweight product compared to everything else that you're seeing. Incorporated glazing and louvers. This was a student housing project we did in San Francisco a handful of years ago. Very little.
Locked in. A big ass. Yeah. TS tough, I'm not gonna lie.
So this is our form shop. This is where we make all of our wood form pieces and our rubber mats. So this is one of the jobs you were looking at out there. This is what a form liner looks like. It's super high density rubber, and that's what we'll cast panels over. But it's basically a master mold that we can fill up, so you can do a lot of crazy stuff.
Someone was asking earlier, Doug said there's like maybe around like 200 people on site today. But when you ramp up, what's the most?
The most we got is about 800.
800,
200 up to 800 people.
CNC machine, so we, we send our models and whatever pieces of formwork, and it gets cut to really good precision. It's pretty cool. I'll let you guys go in there and take a look.
Yeah, it runs on the track.
Thank you very much.
And over here, this is a little bit different. It has screws that move back and forth. But yeah, this is a little bit older one. I kind of like that one better, but it has less capacity for this one. But yeah, it does work pretty damn good. Very accurate. Oh, there you go.
Yes, come around this
Can
way.
you give us, like, cut ones?
At the moment, I have to go.
Oh, okay.
Yeah, back in the day before you had them, you did everything by hand. Wood shop was really large, and then they can cut just about anything to, 32nd of a precision. Yeah, I know. It does.
PVC like this big, and just like a special little square for something. And you're like, but I mean, they're kind of right. It's like, you think about 5 minutes on the computer, you put it in and it's line up, You don't have to like measure a million times and make sure you're square. It does it all for you. All right, we'll keep moving on. But how this works, it's on a track. We've got a drill bit, and so it'll cut the material. Okay, it's a big job.
It's got a 5-axis, so we can do 3D cuts as well, 3D.
Tiesto. Tiesto.
I don't know. I can find out for you. All right, so this is our graveyard here. We're about to go check out our architectural finishes lab. But these are all 4x4s from jobs we've done. So a lot of different finishes. A couple things I'll point out is, this is a sandblast, this is a polish. And so it can make it look like pretty cool, different things you can do, but the polish is one of my favorite finishes. That job there is dorms at Berkeley that we're doing right now. All sorts of different types of bricks, form liners, sandblast, all that kind of.
I gotta move like how we do in PE, bro. Crisscross. Fuck your favorite, bro.
So this is our finishes lab. So this is where I usually start when working with a client. Every time I come in here, we say something different. So this is all stuff that's either jobs that are in the boat, jobs I'm going after, and we're helping the architects get through different decisions. So it's kind of fun to always walk through here. You're going to see different types of things. You're going to see a lot of different form liners, sandblasts, whatever. A couple things I'll point out though is aggregates for precast. So typically, like when you're talking about a casting place or a structural mix, you do a lot of pea gravel, they're a little bit more round rock. When we do precast, we're looking for angular shapes, jagged rocks. And the main reason is we vibrate. When we vibrate our decks, the rocks come to the surface, which is going to, when we strip it, it's going to be your face of your panel. We want as much square footage of rock to show, so when you sandblast it, you're seeing the pretty, all the nice expensive stuff people are paying for, you're going to see it. Right, if you let's just take for an example, you had a bunch of marbles fall to the surface and you hit it with a sandblast, you're just getting that tangential surface, it's going to grow a lot of little dots everywhere. So that is a key difference between precast architectural mix, which is like I said, concrete mix.
I have a question.
Yeah.
With a lot of like picking out what type of aggregate they want, does that affect like the process of casting?
Yes. So mixed performance is where we make and break our budgets, and so a lot of times it's an ebb and a flow. It's not like a la carte where you can say, I want this one rock. We have teams that go up and down California. We're harvesting rock from natural quarries. Even if I harvested rock, let's say in one part of the vein, 6 months later I go back to that same vein, different colors, tones, and textures. And so we do a lot of R&D. They may ask for like a gray mix with some black fleck and some white rock. We'll probably make 8 of them, and then internally look at it and say, hey, which ones perform well? Okay, we're going to show them these 3. right? So there's a lot more work that goes behind the scenes before we get to that final step. So we're always kind of messing around with different stuff as well. So I like to show this one super dirty. This is like granite marble, and then this is a replica out of concrete. You know, it's not exactly the same, but it is kind of cool what you can do with concrete. We use a rubber mat. It will depend. Like we do a lot of material, but it's all about how many casts. So one of our bigger costs. So say 100 casts on that, we're gonna use a rubber mat. If it's like 3 casts, no, probably use it. Right. So it depends on the repeatability of the panels, how much square footage you're casting, stuff like that. Good question. That'll vary depending on the job site, location, size, all that stuff. Generally speaking, precasting is going to be a slight premium. Main reason is it's a better quality product. You know, you're casting or shotcrete, you're not going to get your same finishes. If it's a cast in place, you can do architectural mixes and finishes with cast in place concrete, but it's not very cost effective. So if the design is going to be utilitarian, you know, kind of rough, stuff like that, yeah, cast in place probably is more cost effective in those cases, unless it's a larger scale project. If it's something that's going to have like nicer premium finishes, precast is one of the ones capable of doing it. So, and those are things I look at, like when a job comes across my board, I got to determine how many resources am I going to put on this, what are my chances of actually winning this, and I always start with where do I think I am cost-wise compared to alternate products. And these are like samples that we're getting ready to send all over the world. So different architects all over the country work on jobs. Like we do a bunch of work in Phoenix right now, and we have architects in Chicago, New York, Atlanta that are working here. So a lot of coordination that goes into it. All right.
You make a video of it. Hell, that's fun.
You're gonna have like this crappy quality every now and then. All of a sudden, you see the panel. Good ass quality, bro. What town hall level were you?
About a max out 11.
Okay, I like that, bro.
Yeah, fine or what?
Yeah.
Yeah.
You wanna join mine?
But,
You wanna join mine or what?
I'm not trying to leave mine.
Is it yours?
It used to be good. It's well, at the time it was kind of fucking level 6. Now they're like fucking 13s and shit.
Yeah, I think 18 is coming out like next week.
Clan level?
No,
Oh,
you
no.
mean clan level?
Yeah.
Yeah, you're right. And that was like what? I think the highest right now is like 34 or something like that. 35. But they wore like they wore nonstop.
I was just trying to do the everyone. So yeah, in high school that shit was popping. After high school, everyone like just stopped playing. Now I got like 2 people in there.
Sprinkling or what you're doing? It's called yeah, it used to pop a lot, and I don't know why. It just seemed really like nostalgic. It was cool.
I'm
back
trying to
then.
get back up to like 5 people, but you start small war.
Oh, you're by yourself?
Yeah, well, it's me and like 2 other people.
Oh shit. I mean, I have some alternate accounts. I think I could join.
Alright guys, so that big A-frame is our metal shop. This used to be a random factory guys. So this used to be a sugar factory. Spreckle Sugar, I don't know if you guys ever heard of it. That is the angle of pros for sugar beets. They would load that building from the roof, and that's the angle they would fall in. They try to get as much volume of that building as possible. But we repurposed it into metal shop. They do all of our rebar bending and cutting in there as well as our welding and bit fabrication. Once they get the rebar done for a panel that gets kitted, it comes out here. And this is where they're tying all their ties and stages together. Our real estate, the way we make money is casting panels every single day on that deck. So we do everything we can, never to miss a door. So we're typically building these, 3-4 days in advance, have the panels ready to go. We'll drop it in the deck when the time's right. As you can tell, there's tons of rebar, especially products that are delivered to California. A lot of bin modeling, coordination goes into getting these things right. Something else that's cool is all we dug to it, and then we have a rail blade that goes through a site, so they can deliver. You guys send out material to it? Just deliver. We deliver material by rail. So obviously, we're doing that on the rail. A lot of our metal mill runs where you have much heavier loads getting it over. Larger cubic yardages, right? This is our architectural batch plant, much smaller cubic yardage batches, and we usually have a handful of colors all going on at once at the job. So a lot more bins of aggregates, needs to be a lot more agile, things of that nature. Then we have quality control labs that are right there, so you're testing everything that you're for. And then from there, if it's architectural, either get loaded into a truck or a bucket and sent to our forms, and this is always a truck front loader that gets delivered to our decks.
I always thought it was kind of interesting that their concrete trucks are like backwards.
Yeah, the main reason is we're pouring into a form with guys on the deck, so it's a safety precaution. They got to be able to see all the guys working plus pouring into this. But yeah, I never appreciated that. That's all I ever saw. I mean, somebody's like, what the fuck's wrong with this truck?
Well, it makes sense, because otherwise you got to get out of the truck and, they never have to get out, right?
They never get out.
Yeah, I didn't even think about that, but that's not the typical way I've seen them.
No, it's backwards.
So all these bins are different mixes that we have going on in the plant. They'll get cleaned out, but you can even get, the darkest of sands. That's what helps us get our dark colors.
Black sand? I don't even know what I was thinking.
Like when we're stressed out, so now we're just like, no, I've noticed it.
Damn, low-key, you guys might not be able to hear. I'm not gonna lie.
Make sure you grab the earplugs. Oh, look at that.
Come on.
Does it work?
Yeah.
Oh.
That comes with it, dude?
There you go.
Alright. Everyone all good?
Alright, so I'll try and do my spiel real quick, and then we'll walk through this. On the right side here is all of our custom fabrication. So that's going to be embed, metal frame, what have you.
That's fire.
Make sure you guys put your safety glasses on.
Yeah, we have a plate. Thanks. I'm notoriously pretty bad. There's a lot of photos of me with no PP. We have plate cutting over here. We have a plasma cutter. I'll show you guys. We have a robotic welder in the back. We have some weld shop. On the other side is our automated rebar bender. So we're gonna go take a look here, then we'll swing by the rebar, and then we'll head out the other side of the building. All right. This is our plasma cutter. We do a lot of miscellaneous embeds, things of that nature to help protect panels in the building. This will cut any shape, any slot, really clean and neat. This is just some connector material they're working on here. This is a plate cutter. So when you're taking just, most of our embeds are cutting from plate, and then we take that and we'll weld it together.
That was tough, huh?
Pretty much always keep up with our It's great for a high repetition embed. So when we do double T's, we're using what we call these hangers. That's what comes out of a stem that will rest on a ledge or a bearing or something like that. We usually use this automatic welder. It's like a rotisserie where you have one guy working it, he'll set up a couple items, he'll rotate, he'll weld everything itself, and he's pulling the completed ones off and putting the materials on the next. It's usually like a cycle. It works great for high repetition. Anything that's slow, it takes too long to program. And, people
So what's up? Yes, I said what's up. Huh? You said what's up.
These are all rebar benders. Automatic.
There's the rebar.
Rebar will get tools, larger bars, larger diameters of straight bars, different size diameter bars. So we can make all crazy types of shapes and highs. So those are orders. And then they'll tag it, hit it by panel. Those get then shipped out there and assembled. That's great. Nothing. Touch rebar. So this is typically it's covered in stored panels. We just finished delivering a 15,000 piece building up in Idaho, so it's looking a little empty. But this will soon be stored with more projects, typically filled with double T's. So one of the things our young engineers do is they have to take these 70,000 pound panels. We're stacking them and storing them efficiently. There's a lot of engineering that goes behind that and thinking about different wind loads and things that you're going to experience here at the plant.
Check out the rebar. It's nice shape. Kips. First time I've ever seen that unit. that's fire.
I had him on earlier, and I was like, I don't know if I should take him in there. And then he's like, oh yeah, we gotta wear your plugs. I was like, fuck. I was like, let me go grab him.
I had to show the camera real quick. It's fire.
Did you?
Man.
Yeah. A bunch of attachments you can add to this fucking app. Right? They have like one that has like lenses that come down, but they're a little too bulky. I prefer glasses.
Yeah.
They're cool.
Is that helmet from Milwaukee or what?
If there's area, one area, I focus on development engineering, closing deals, and kind of what it takes time to kind of whole pre-construction packaging. So this is a frame real quick. This is our hybrid system that has that 2.5-inch concrete. So you have mesh. This is, again, these are all ready for tomorrow's pours, right? So they're getting prepped, quality controlled, checked. They'll get moved to the deck. Where'd you go? Sorry, where'd you go?
You won't get on.
Just for rigging. Just for rigging. So they got
Sorry guys, I can't hear. I don't know if you can.
taking a panel from here, how do we store it, how are we going to flip it with different hoisting equipment. Trying to get as many panels as we can. But the one thing that we run the whole way through, and it's because we're cool, we got 4,000 PSI, high strength. We don't, if we were going to have a
Holy shit.
that's totally existing cable. If you were going to do that as a cable panel, it costs a lot of money, take a lot of time. So we basically run the strands the whole length. The next morning after the concrete here, we'll cut the strands here before they are These are the embeds. We were talking about embeds. These are precisely placed. The rebar is embedded in the concrete. What you get a plate on the side. Take all. We're going to the sun. Yeah.
Got some Mexican brothers here.
Oh, yeah.
I was gonna talk to them, but I don't know if they'd get mad.
Start speaking of it?
Huh?
Start talking?
Yeah, start talking. Huh?
Do you edit the videos?
Nope.
Watch your step, guys. Good shit.
for nanotube.
The reason this one is going on wood, we put maybe
Oh, Chase Center too?
a box on top. We're casting in here.
Huh?
The best one? The Warriors Center.
Chase Center.
Just getting embedded into the concrete here at the deck. So a lot of these things, I mean, the attention to the detail about you'll see the back of the terracotta is dovetail. We're gonna go see a bunch of panels in this strip. All right, so here's a couple panels from this job. The job we're doing for Stanford. They have a lot more money than Sac State, Cal Poly, so they can afford to do this type of stuff. So this is terracotta, all sorts of different types, and then this is stone. So stone is really cool. It's not necessarily used as much anymore because of the premium, but stone is very soft, and we have to worry about concrete shrinkage. We don't want to crack the stone. So instead of being embedded like terracotta, this is actually debonded from the concrete. So we'll place stone in the deck, we'll drill in pins, put a layer of like a visqueen plastic over the top so the concrete doesn't cure to the stone, and just the pins anchor it into the concrete. So if it does have shrinkage and stuff, there's a little bit of play in the pins, not putting stress into the stone. And like for something like this is where the client flies me over to France, I gotta go pick out rock, go to Portugal, cut it, and then I gotta come home. So I'm always willing to sell stone if they want to buy me a first class seat. Don't see it very often anymore. Data center we're going to be doing in Reno. Got a different kind of finish on it, has some form liners, but what I like to do, this panel's 55,000 pounds. And so part of our job is saying, hey, how do we get this from here to Reno installed? And then when you install it, you have to like temporarily connect it. While you make the connection, you can find alignment. How is that getting done? So that's what I loved about Park Pacific when I first started. It's like you get to be an engineer, you get a little bit of general contracting experience, and you also get to actually build the shit. So when you walk away, you got a full building there, and it's pretty cool. So our engineers stay with the job from start to finish. And unlike like a general contractor who's maybe on a job for 3 or 4 years, you know, from start of development through exterior finishes, our jobs are fast. So you can be doing 2 jobs at once, 12-month cycle, you're on another job. So it's kind of a little unique in that way.
I always say a joke when we were doing the Sawyer. My wife Melissa was in charge of Park Pacific, and she was working with Michael in the salon, and you and one other guy too. I don't think you ever yelled at her.
I never did. I'm the nice one.
As you're going up on the building, you have to make adjustments structurally, and I don't think the panels had been cast yet. But the thing is, you know, these are all engineered to go exactly where they need to go, and they're under the assumption that the building is going to be how it's been designed. But if there's a change, they have to go back and re-engineer things. And so I remember she'd be on phone calls and be like, hey, we had to move this in bed, or we had to do this. And they would be yelling at her. They were so pissed. And she's like, I don't care, I'll pay the change order, you know, whatever design fees. And these guys were pissed because they had to go back on their own time and re-engineer these panels. And so it was personal to them. And I was just telling Sergio that it was when Daryl was giving her tour. Oh, yeah. She was almost in tears when she saw, what's that project with the super thin corner? That was like her
Mission Rock.
Mission Rock? Yeah, she was almost in tears because that was like her baby. You know, you go through months and months of development, right? All the way from engineering to like being able to see it and then see it on a building. Like, that's a big deal. It's probably super satisfying.
Super satisfying. Every job we do is fairly unique, so yeah, like all the jobs I've done, I got like a sense of pride you get when you see them when you're out there. So yeah, it's pretty cool. And to note, the design changes he's talking about, so they poured the fucking slab 2 inches below, if I remember right. So it wasn't like, oh, there's a lab here. I don't remember. It was like the whole fucking facade had to change. We paid the change order and moved on. We got paid. 10 years later, he remembers. I'm fine. Neither of those guys. I'm over it. They weren't the best. They're pretty honorary. Yeah. Yeah. Unless I have a lot of patience. Anyways, okay. We have that's another. So that's kind of our storage yard. Those panels are going up in Reno as well. Let me see how much time I got. 15. Let's go do panel finishes really quick, and then I got to wrap it up. I got to be on a call at 15. This is a parking garage we're doing at UC Berkeley. This is the exterior frame. It was kind of cool. They rounded the corners, added sandblast. It's a nice feature. It looks really cool out at the job site. And we'll go see some of it being done.
These are cool too. I always like seeing these cranes. These are like giant, like gantry cranes on wheels. So how do they move these around? They don't use a forklift, right? Because it would damage the, the panels. They use these massive cranes that have wheels that actually drive around like a
port.
Yeah, like a port. Yeah, exactly. Same idea. That's cool.
Well, you want to wait to camera?
A lot more safety regulations.
And he was back to work on Monday.
Oh yeah. Give him a peg, get him a deck.
Damn, it's hot. Thank God I didn't bring a sweater. Fuck.
Yeah, so what we do here is we'll put the panels out here. Welcome to the beach. This is where we take high pressure sand and take off the cream layer. So this is a column for that same parking structure that those beams will connect to. It's about 60,000 pounds. That's about roughly about as big as we want to go for trucking purposes. But it's
Does it just look like a pressure washer that comes out here
No,
and
so
sandblasts it?
like, have you ever seen a car get sandblasted? Same thing. So you got bins of sand and high pressure air.
Oh, okay, yeah.
You basically are shooting an abrasive at a high pressure, and it will strip off the screen plate.
You guys are understanding, like this is what the panel looks like when it's stripped, right? And then they sandblast it, and they sandblast all the cream off and expose the aggregate.
Yep, this is what it'll look like. Now, the face won't have as many bug holes, but yeah. Yep, form oil, remediation.
How do you want us to fill out our map?
And that was the same thing I had, you know. If anything, I'm mostly looking for like
Okay. So it's like, we don't have
no, I
the
just,
top part.
someone already asked that question once, yeah.
So yeah, this is the last job we were doing at Stanford. Had the terracotta, had the stone, also has panels that have nothing on it and different levels of sandblast. Kind of a cool.
So they mask it off, or they actually able to cut?
We'll mask this off like with shields.
Oh, okay.
That's how we do it. But this is about as big of a facade panel as you can get to get within your height, your width restrictions down the road. We sometimes push it a little bit, maybe have to deflate the tires, but yeah, whatever we can do to get large panels.
So when it comes to transporting them, do you guys transport them vertically, laying down, or?
It's all equations. So if it makes sense to go, like if it's a cast in place building, you have 10-foot floor to floor heights, you can get those panels vertical. So I'll get 4 panels on a load. If I'm doing a steel building, like a medical office building, floor heights are 15 feet. You can't get that tall and get under underpasses down the freeway. So we'll have to put them on like 45-degree easels, right? The caveat is you're getting less panels per load, but you're going to do bigger panels. So you can usually do a math equation based on where it's going, how heavy the panels are, and see what the most cost-effective approach is. Architects want the biggest possible. They don't like joints. So the less joints you can have, the better.
Do you guys have your own transportation division, or do you guys outsource that?
That's a great question. We outsource our trucking. We have a lot of our own trailers for the fleet. Main reason for that is just like the ongoing overhead to maintain maintenance on trucks is a lot. Secondly is insurance purposes. So they basically take accountable for the panel once they rig up to the time they get to the job site. So if anything happens in transport, it's on them.
For example, this right here, if anything happens to a load of these panels, what is that?
I got to recast them or fix them. And then if it happened while the truck driver had the panel driving, he's going to pay me for it.
What's that for?
A panel can cost 20 to 30K.
And you put 4 per, so.
Yeah, but we don't ever really have damage on trailers. The only times we ever see that is like if there's a car accident. Like we're engineering the stanchions, the rigging, the overturning, things of that nature. And these are so critical that there's tons of factors of safety on it. If a trailer of this size falls over, you're lucky not to kill somebody. Any other questions? If not, we're gonna head on back.
Am I good to end the video, or should I keep?
Yeah, you're good at it.
All right, guys, we're heading out. It's Clark Pacific. Make sure you hit the like and subscribe button. Trying to hit 5 subscribers by the end of the year. All right, peace.